What is expressed sequence tags?
EST are fragments of mRNA sequences derived through single sequencing reactions performed on randomly selected clones from cDNA libraries. ESTs represent partial sequences of cDNA clones 300 BP to 700 BP. EST pre-processing reduces the overall noise in EST data to improve the efficacy of subsequent analyses. Vector contamination is prevalent in ESTs and need to be clipped before EST are clustered. Purpose of EST clustering is to collect overlapping ESTs from the same transcript of a single gene into a unique cluster to reduce redundancy. Two approaches for EST clustering: stringent and loose. Stringent conservative clustering method uses single-pass grouping of ESTs resulting in relatively accurate clusters. It generates shorter sequence consensuses. Loose is liberal and repeats low-quality EST sequence alignments many times to generate less accurate. Loose generate longer sequence consensuses. Once consensus sequences, putative genes, are obtained from assembled ESTs, possible functions can be assigned through downstream annotation, achieved via database similarity searches, employing familiar freely available tools and databases. First step in translating EST sequences is in identifying the protein coding regions or open reading frame from consensus EST sequences. Or predictor designed specifically to identify protein coding regions in EST-derived sequences. Once a putative polypeptide is obtained, its function can be predicted by matching against non-redundant protein sequence, motif and family databases using an integrated tool such as InterProScan. Protein sequences are better templates for functional annotation. Gene discovery, aid gene structure identification, establish the viability of alternative transcripts, guide SNP characterization and facilitate proteome analysis. Providing markers for mapping, providing candidate disease genes, and analyzing gene expression. A complex multiple-step process that makes use of several distinct programs. Clustering the sequence based on similarity and then assembling them to produce contigs. Purpose: reduce the search space when performing similarity searches. Estimating the number of genes represented in the dataset. Use when there is a large-scale sequencing project in which thousands of EST are generated daily. Can store, organize and annotate using an automated analysis pipeline. Automatically clean, cluster, assemble, generate consensus sequences, conceptually translate and assign putative function.
Created using Powtoon.